Hello guys, let's do it. Analytical geometry for grade 12, ne? We introduced this thing of circle geometry. And right now we're gonna talk about the equation of a circle with the center as the origin. Alright, so you have your Cartesian plane, right? So you have your Cartesian plane right there, and you have, oh no, you have your circle. Nice. You have a circle, ne? And the circle that you have, it have the origin, which is point 0, 0. Right, here's a point. Let me call it point O, ne? Coordinates 0, 0. Right. So we are trying to talk about the finding the equation of this circle. Right, finding the equation of the circle, or perhaps doing calculations that involve a circle having a center 0, 0. Right, I wanna perhaps remove this and put them here. 0, that is O for origin, and then the coordinates are 0, 0. Right, so in me trying to determine or find the equation, this is not the derivation of the equation, right? It's something perhaps you need to understand, but what you need to know is how to apply it, right? Yeah, my video. This one, I will teach you the theory and the derivation and how to apply that knowledge. Sure. So say you have a point from the origin, a line moving from the origin to the circumference, right? What is that line called? There's a line that moves from the center of the circle to the circumference, right? We call that line, what do we call this line? We call it R, right? We call it the radius. It's a radius, ne? And so I'm just going to use a small letter R, right? And say here you have a point on the circumference, you have a point P, which is x, y, right? And cool. Perhaps I can say I have there's a perpendicular line, or there's a line from P to the x-axis, which is also perpendicular to the x-axis, right? And let me call this point K. Right, but now I want to ask you a question to say, using distance formula, if I want to find the distance for R, how will I do it? Yeah? So R, you see, it moves from the center to the circumference, and it is the radius, right? So to find R, I'm going to say distance formula for R is going to be, right, y1 minus y2, and then I'm squaring it. Then there's a plus, we have, what do we have? Come on, bro. Think. We have, oh my god, x1 minus x2 squared. And that is the formula, or the distance formula that we use. Né? So now remember, R is OP, right? Or perhaps let me rather say distance for OP, right? So here, this is point, let's call this point 1, and let's call that point 2. So y1 is going to be 0. So you have a square root of, there will be 0 minus y2, which is what? Which is y2, there it is y, right? And then we are squaring the whole thing. x1 is 0 from the origin, minus x2, which is x from P, squared, and you're gonna end up with y squared, right, plus x squared, right? And remember, this is the distance for OP, which is also R, right? R being the radius. So what does that mean? That means R squared equals to y squared plus x squared. And my friends, this is what we call the formula of a circle with a center 0, 0. So like basically this is how we find it, and this is the structure of your formula. If you have a circle and you know that the center of that circle is the origin, implying that the center of that circle is 0, 0, 0.00. The formula is going to be structured like this, right? This is how it's going to be structured. It's your radius squared plus is equals to y squared plus x squared, right? So now we're going to try to apply all this knowledge we have just learned, do a couple of examples, and let's not waste any time. Cool. So they say cool. They say a circle with a center O. Cool. So we see that the center of that circle is 0, 0, right? And it's going through points. These are the points, right? Point P and point Q, right? Plot the points and draw a rough sketch of the circle. Cool, cool, cool. Cool. So first thing first, I have my Cartesian plane. And there's my circle. Try to make sure that it's like at least somewhere in the center. Alright. Cool. So there's a circle. I'm just gonna say not drawn out to scale, but yeah. And then I have point P, né? So this is the center of the circle, 0.00, right? Point P, its x is -5 and y is 5. So this will be perhaps a point here, right? This is point P, which is what? -5 and 5. And then we have another point here, which is the point here, right? It's gonna be this is point Q, which is 5. Oh no, I am actually lying to you guys, yo, because yeah, so x, yes, x is positive, but y is negative. So we're gonna have it somewhere, say it's gonna be here, right? This is point Q, and we have 5 being x, which is positive, and -5. Ooh. Right, and this is the rough sketch of our circle. We have 0, 0 there at the origin, and they say determine the equation of the circle, right? So determine the equation of the circle, right? So remember, I said that the structure of this thing is like this. You have r squared equals to y squared plus x squared. This is the structure of a circle. A circle. This is the structure of the equation of a circle that have 0, 0 as the center, or that has the origin as the center. This is how it's structured, right? So the first thing, right, I'll show you this is the quickest way. You just go here and say r squared is gonna be -5. So this time around, you see that I'm using Q, -5 squared plus 5 squared, which is 25 plus 25, that is 50, right? And then you will then say therefore r is gonna be square root of 50. Let me see, square root of 50. Can't we write it? Cool. Square root of 50 is just 5 square root of 2. How is it? Yes. So this is r, ne? So then I can say that, in fact, oh my god, in fact, I don't need to go here, man. I'm realizing, right? I don't need to go here, because what I can say is because I have to write it as r squared. R squared is 50. So I'm gonna say 50 equals to x y squared plus x squared. I don't need to find r, right? So I just do this and I have my equation. This is the equation of the circle. So, and by the way, I used a point in this one, but then you'll realize that even if you use this point, you're still going to get the same equation, right? Because you have a -5 and you have a 5, you square them, and then you add them together, the answer is 50. You understand? Cool. Then we say here, calculate the length of PQ, right? So finding the length of PQ, we'll use a distance formula to say distance formula for PQ. It's gonna be, of course, you have y1 minus y2 squared plus x1 minus x2 squared. So that means we're gonna have y1. So let's start with that will be 5 minus 5, right? It's the 5 from P and the minus 5 from Q, right? So P is 0.1, and that for here we have minus 5, and then I'm gonna have, what am I gonna have here? I'm gonna have minus 5 squared. So it's minus 5 minus 5, x1 minus x2, right? And that means I have in each, I'm gonna have this is gonna be plus, so 5 plus 5, that is 10. I have 10 squared plus, this is gonna be minus 10, and then which is minus 10 squared. So that means I have a 100 plus 100. I mean, I'm just wasting time now. This is a square root of 200. Square root of 200. Let me see, 200, and it's just 10 square root of 2. Right, let's hear. Explain why PQ is the diameter of the circle. So now we are hearing the familiar word diameter. Remember, it's diameter is a line from the circumference to another circumference passing through the origin, right? A straight line that moves from the circumference, from one point on the circumference to the other point on the circumference, passing through the origin, that is the diameter, right? Which is also twice a radius, right? So you can then say that radius is gonna be square root of 50, which is 5 square root of 2, right? And then you say diameter, right? So you're gonna say your diameter, right? Diameter is equals to 2 times the radius, which is 2, into 5 square root of 2, which is 10 square root of 2, right? And then you realize that, oh, the diameter is twice my radius, right? Or the distance you have there is twice that of the radius, which only means that PQ is a diameter, right? Let's move to the next question. So here they say determine determine the value or the values of G. If this point, right, is on the circle, so you have your circle as x squared plus y squared equals to 19, and then if you want to find the value of the values of G, you will substitute x. So we have square root of 3 squared plus y squared equals to 19. We're gonna get y squared equals to 19. This is 3, so we're gonna have minus 3, right? And then you have 16 being y squared, right? Which means therefore y is gonna be plus or minus 4, right? And this is coming from plus or minus square root of equals to. So when you put a square root both sides, this side, you're gonna have a plus or minus, right? Or also, like, someone could actually say that I have y squared minus 16, which is equals to 0, which is the difference of two squares. And that means that's gonna be y minus 4, right, into y plus 4 equals to 0, meaning that y will be equals to 4 or y will be equals to minus 4. Any way actually kind of matters. I mean, you choose the way you want to solve these kinds of problems. So, but we get it. We have -4 and 4. And then here they say, it's a new question. A, which is ST, okay, it is a point on a circle, okay, with a center of with the center at the origin, and the diameter is 40. That is so cool. That is so cool. If the diameter is 40, what is the radius? 20, right? And also, what do you know about this thing? About the circle in the origin, what do you know about a circle which have the origin as the center? You know that the structure of the equation is r squared equals to x squared plus y squared, right? So they say that the diameter, you will say radius is half the diameter, right, which is a half of 40, which is what? Which is 20. Actually, let me read the question. Determine the possible coordinates of A. Okay, I'll come to that. We need to do this first, right? You have your radius, which is 20. You then say, therefore, you have 20 squared equals to x squared plus y squared. And that, therefore, you're going to have your equation as 400 equals to x squared plus y squared. Now let's answer the question. Determine the possible coordinates of A, right? Here is A. If the value of S is triple the value of T. So what are these people saying? They say that the value of S is triple the value of T. That means S is equals to 3 times T. Right. So now you substitute point A. Right. Remember, A is S and T, I think. Let me check. S and T. Yes, that is A. That is your coordinate A. So let's substitute it on the equation. You have 400 equals to x squared, that is S squared, plus T squared, right? And then here we have something that say S is 3T, right? So you go here, you like for S, 3T squared plus T squared. Then you're gonna have what are you gonna have? You're gonna have 9 T squared plus T squared, right? And you have 10 T squared, right? You still have 400, you divide by 10, right? You're gonna get 10, 10. And this is T squared, and here you're gonna get 40, and therefore T is gonna be square root of plus or minus square root of 40, right? And therefore S can be 3 into negative square root of 40, or S can be 3 into positive square root of 40. So these are your possible values of S and T, right? Let me see, square root of 40. Yeah, and then they say determine the possible coordinates of A if the values of S is half the values of T. Yeah, so this one you will answer it using the same ideas, the same way we did number A. Yeah, you will do this one the same way. So let's see. Cool. So let me end the video here. I don't want to make it long. We'll have more examples, of course, of these on the both the last and the second last video. See you guys.